Thank you very much for having me here today. This is a pretty cool themed event. I love it. But this is a very fast talk, so we'll keep it quick. This is all about this is a great session I love to talk about because it's about something that's free, that's available to anyone. It's in SQL Server. You can build this anywhere. It's a really great tool. It's basically costs next to nothing to build, and it's really fun. These are the sorts of things that we do that give us a lot of value, but don't cost us very much, which makes this great. So just diving right in, this is me. I've done a lot in the SQL Server world. I presented a lot of events. I've been published. I've organized our own SQL Saturday out in Albany, which I'm hoping will return next year. COVID was kind of a disruptor there, but we'll have some sort of event out here. We barbecued this year, and that was great. So this is me. I will, when the session is over, tweet everything out. If there's any questions, I can answer them in the chat, or I can answer them out on Discord or on Twitter later, wherever is good for you. So let's dive right into it. What are we here for in 10 minutes? We're going to talk about how to make date calculations faster and more efficient and more reliable too, basically by just defining what the calendar table is, what can we do with them. We'll slide some demos into a lightning talk because it's crazy talk and it's a lot of fun, and then we'll be done. So let's go. What is this? What am I talking about here? What is a calendar table? And basically all it is a table that contains dates and then lots and lots of derived components of those dates. Everything from month, day, year to the name of the day written out, the day of the year. It could be the day of the month. It can be, is it a holiday? So on and so forth. So lots and lots of date components. And when I say lots, it really can be lots. There's no limits here. We can really have as many as we want. The real purpose of this, the reason why we like it and why we want it, is because it eliminates having to write lots of date math on the fly. By having a reliable table that has everything in it that you need already, you don't have to go putting date parts and date diffs and all that stuff into your code and then relying on it always being correct and having to copy that crazy code all over the place. This can become especially nightmarish in analytics where you can really have like serious, like I want the quarterly report, but I want to exclude holidays, but I want to have Saturdays, and just it gets crazy. It gets crazy very fast. And it's really what we're trying to avoid are things like this. We've all seen this kind of code before, whether it's in SQL Server or elsewhere, whether it's an app code, we're familiar with this. It's ugly, it's hard to read, and it takes a while to figure out what this means and what we do with it. And for anybody having to maintain this code, it's a challenge. So the easiest way to really talk about calendar tables is dive right into a demo, no delays. And so here we are. This should already all be created. Let's make sure it is. It is, great. So what is this? Is a giant table. The first column is nothing but a date. It's the PK, it's clustered, that's everything. That's your key for everything here. And then from that point on, every other column in this table is something derived from that date. The written out string, great for concatenating into text you're writing out. Month, day, quarter, year, day of the, you name it, week of the whatever, month of the whatever. What's the first and last day of the week, month, quarter, year? Is it a leap year? Is it a holiday? What's the next and previous business day? And so on and so forth. It's a lot of metrics, and you may have other ones that aren't here, and that's great. You may also think that some of these aren't very helpful, and you could easily remove them. This is a very customizable thing that we build that is an aid towards any processing we want to do with data that involves dates and chunks of dates. I page compressed it to make it smaller. There's no downside there. This table is not going to be very big in the grand scheme of things. Next thing we do is we build a proc. This is a very methodical thing. It just goes through and iterates, and it'll go through and one by one populate dates. And all the math is here. So the math, the date parts, the casts, the converts, all that ugly stuff that you put in your code goes into this proc. And then we execute it. It does a whole bunch of stuff with holidays and so on and so forth. And when all is said and done, we have our calendar table. And it looks like a lot of code, but it's really just very methodical stuff. Each step is just saying, give me a piece of the date, and then we're going to update a variable and throw it into a table at the end and keep going. And at the end, I populate a total of 120 days, 120 years into this table. It took about 2 minutes to do it, so I'm not going to do it right now. It's already done. You don't want to watch that, but only about 2 minutes to populate 120 years. 120 years sounds like a lot of data, but it's really not. We'll come back to that in a moment. So what does this calendar table even look like? To use the right database first, right? And you can see things. So here's a month of data. And here's what the data in this calendar table looks like. You see we have our date and then just mountains of derived metrics afterwards. And this is great because you can join to this from any date column or date time or whatever date part you want and pull out whatever metrics you need. This is really, really helpful. So I want to go back and talk quickly about what's the point of all this? Why are we doing this? Before I dive into more demos and lots of detailed examples and some of the crazier things you can calculate, why does this matter? Number one, which is already kind of obvious, is you can simplify code. You can make it simpler, easier to read, and easier to maintain. You can help performance. If there are certain date calculations you rely upon heavily, you can index your calendar table. Now, if you think about it, the calendar table has 120 years in it and 365-ish days per year. That's not a lot of rows. We're talking like 40,000 rows of data, which is nothing. That's tiny. It's a megabyte or something. So it's really small. So you can improve performance by indexing the snot out of this table and using it because you can. You can also make your code, this is huge, you can make your code much more maintainable because now all of this logic is in one place, not in many places, and that's a huge saver. You don't want to take big complicated code and copy it to 20,000 places in your app because now you got to maintain that in 20,000 places, and it's easy to make a mistake. Certainly with code that complicated. You can standardize all of your date-based business logic and have a source of truth for it, which is huge. And you can get date ranges out of this. You can join against it and create date ranges very quickly to put a data set against if you want. And a huge benefit of this is it's really cheap. A megabyte table costs next to nothing to maintain. Once you've created it, it's done, and you can use it forever. And you can update it and add to it later if you want. But it's a great way to build a source of truth that makes our lives better. So let's jump back now and talk about some demos. I first wanted to show really quick, not all things that we calculate are simple, like a one-liner with a date diff. A great example is Easter. Calculating Easter requires a lot of math, a lot. For example, you can make a function here that will calculate Easter using the Gaussian algorithm. And you can see this is not simple. This is complicated. And I don't want to put this in code in many places. Again, I want to do it once and never do it again. So let's dive right in and talk about it. How big is this date table, this calendar table? It's 43,830 rows for 120 years. It's not that much. So we can simplify code. For example, this statement here has a big messy pile of stuff to find all the orders in Q4 of 2013 that occurred on a Thursday or Friday, but not on Thanksgiving. And we get rows back, and that's great, but it's ugly. By joining a calendar table, we get rid of all this date math, and now we can very clearly read it. Calendar year, 2013. Calendar quarter, 4. Day, Thursday, Friday. Holiday, not Thanksgiving. So the code isn't shorter, but it's way easier to read, and we get back our results just as quickly. What else can we do? We can generate date ranges. You can take your calendar table, select from it, and then left join a data set to it. And by doing that, we can fill in the blanks. So our data set looks like this. It's some order data for 12 total days out of a whole year. But let's say I want to see the zeros in there. We can do that. We can left join the calendar table, and now I get all of my dates back perfectly. I have zeros, plus I have whatever numbers happen to appear in there. So a very convenient way to generate date ranges. If I need date components as part of this, very easy to pull, get, and use. We can correlate this to holidays, weekdays, business days, and it's not complicated. For example, give me everything in 2014 that didn't occur on a business day. There's my sales list. I can group stuff very easily. I can group by quarters and years because a lot of analytics relies on quarterly reports and monthly reports and year over year and that kind of stuff. Again, very, very simple. We get what we need, we group it, and join it against the date table, the calendar table to get what we want. We can use baseball stats too. I have a big giant baseball stat database here, up to date, has everything in it. And I can say, hey, give me all the baseball games ever that occurred on Easter. And it'll search through my giant, massive pile of baseball data and return all 559 games that occurred on Easter before 2021, ever, going back to like 1886. There we go. And all I need is a little bit of extra code to join this cable and say Easter. I didn't need to do a mountain of this crazy code. I already did all that hard work, and now I can just kind of live off it, and that's great. Or let's say, for example, I wanted all the 2018 ball games that occurred on weekdays. Calendar year 2018 is weekday 1, weekday Monday to Friday, at least in this part of the world. Get all the total runs scored in games on Wednesdays at night, but not on holidays. Again, these things sound crazy, hard calculations that require a lot of work, but at the end of the day, they can be made simple with a calendar table. We can get sums, Wednesdays at night on holidays, total runs scored, and so on and so forth. So we get the idea here. So what's the point of all this in the end? we've made our life a lot easier. This helps us a lot. It makes our life easier. We have something that's easily maintainable, inexpensive, and simple. So I highly recommend, if you have never used them before, consider using a calendar table to centralize your date calculations, to improve your performance of queries that have complicated date math in them, and to make your code easier to maintain, easier to read. It's a great tool, inexpensive, and it's fun. I will leave this here on me in case anybody wants to tweet me or ask any questions. I think I'm out of time now, so I will stop. But it's a cool tool. I like it, and I hope you do too.
All right, thank you. Ed, you actually answered the question I had, which was which Albany. So right there.
Albany, New York, not Albany, Georgia, in case you were wondering.
Well, I was thinking maybe Oregon, but yeah, I'm actually from just outside of Schenectady originally. So
Really?
that's where, yeah, I was
Cool.
technically I was born in Albany, so. Yeah.
True story. I one time accidentally booked a flight to Albany, Georgia instead of Albany, New York. The airline was very nice and fixed it, but it was an accident I made like many, many years ago. It was embarrassing. Always check the state you're going to. Don't assume there's one of something. You discover it very fast.
Yeah. All right. So did anybody have any questions about using the calendars? Or calendar tables, I should say. I think that's going to be very helpful for folks. Somebody's asking about scripts.
Sure. I will tweet out the scripts and put them in the chat as soon as I finish. And then feel free to contact me if you have any questions or any comments or thoughts. I'm always looking for ideas, so feel free to contact me.
Okay. And again, if you could put those also in the Discord chat as well.
Sure thing.
And Bradley says, awesome. And then Scott asks, how do you handle fiscal quarters that are different?
Great question. So I've actually built this in the past. I left it out of the demo here, but you can do like 454 and like different fiscal calendars in the same exact fashion. You can have your date and then have like, day of the week, day of the month, day of the quarter, which fiscal quarter is it in, and build additional dimensions for that as well. So it's really just additional calculations that you work into it. And I've used those in production environments before for a commercial company that did order processing. And so I've actually used that exact functionality before. If you're interested in that kind of code, contact me. I'll try to dig it up and send it over. I left it out of this for complexity's sake, but you can do that, certainly.
Okay. So any other questions? Okay. Well, another thing I noticed is on your shirt you have a nice, chemical compound. So that's always good. A chemist is always good.
Caffeine is good. Caffeine is actually caffeine, the valuable one. We like that one.
Thank you, everybody.
All right. Thank you very much.